really quickly want to introduce myself. Enjoy the night.
So, since nobody else is announcing, we have Dick, who is the founder of our Scala Bay. It was called Scala Base, then it was the S letter. Dick will talk about the...
Yeah, I don't know if I can try with the mic. Can you guys hear me without the mic? This is my normal speaking volume. Yeah? Can you hear me back there? Yeah? Alright. I'll skip the mic then, unless this is not being recorded or anything, right?
It is.
Oh, so do I need to use the mic for that?
It might help.
Okay.
It's not going through the mic, but it might
It's
help.
going to be interesting when I'm coding, but I'll see what I can do anyway. So, originally, Vlad asked me to do this talk. I'm doing all sorts of stuff right now, and just to give you a bit of background, I originally had intended to do a talk on the application of game theory to Nash equilibrium in Scala. And after it would have been really interesting, right? Except that about 3 weeks in, we realized it wasn't going to work. And we actually found a bunch of resources online that said that computationally, Nash equilibria are notoriously difficult to find. And there's a whole area of like PhD research into it. Basically, we abandoned it as a bad luck. And so after that, I thought, oh crikey, now I've said I'm going to talk about something at the Scala meeting, and I don't have anything to talk about. So I was inspired by Shadaj, who has a history of talking about really cool stuff. And I thought, what have I got that I can talk about that's kind of cool? And so back, oh gosh, it must have been about 6-8 months ago, something like that, I got one of these Amazon Echoes. Does anybody have one of these? Who has one? Okay. Is this not the coolest thing ever?
They're fantastic. My family is demanding them. I got one Google to try it out, see what it's like. My family is demanding their own.
I know. Everyone in this room should go home and buy one of these after they get home tonight. It is the single best gadget I've bought in the last, I don't know, 5 years. The thing is amazing. So first of all, I feel we should introduce Alexa. Say hello.
Hello.
I think it's only polite she introduced herself. So anyway, this is the Amazon Echo. Basically, what it is it's a natural language parsing environment built into some not too expensive hardware with a decent Bluetooth speaker and a bunch of other stuff in there as well. I think it's actually a profound shift in the way that these human interface devices are designed. Probably all of you have either Siri or Google Now on your phones, and they both suck. And you know why they both suck? Because as soon as you ask them a difficult question, they show you something on the screen. Okay, now you're driving or you're out walking the dog or something like that, you're trying to get stuff done, and it's like, you need to look at the screen. This doesn't have a screen. They couldn't chicken out on this one. They had to do it right. And it's early days yet, but what is amazing is the speech recognition on this thing is uncannily good. A lot of the natural language, and I've actually been doing a lot of work with natural language classifiers recently as well. IBM's Watson has a natural language classifier in it, which I'm using for some stuff. This is probably on a par with what that can do right now. It doesn't have the back end that Watson has. It doesn't have the giant neural network figuring out that hamburgers and ground beef are the same thing and that sort of thing. But the abilities this has in a lot of ways are actually a little better than that. It seems to do better on the speech recognition and stuff like that. And right now it's early days for it. There's a bunch of stuff that it can do. There's a lot more that it can't. But one of the things that it can do, and it's a bit tricky at the moment, but it's certainly doable for anyone who's done any Scala programming, is you can write your own skills for it, they're called, basically the little programs that you interact with. And you can host them on Amazon's Lambda service. And you can write them in Scala. And Amazon's Lambda, I'll talk about this a little bit more as we go through, but Amazon's Lambda is just a way of running functions in the cloud, in that cloudy thing everybody talks about. It's actually really nice. Basically, you define something that fires based on an event that triggers. The events are numerous. There's things like a file showing up in S3 or Amazon's SQS or SNS services, something changing in Dynamo. There's all these different triggers that can cause these things to fire, and you don't get charged anything at all until your function actually fires up. And when it's triggered, it starts to work. They charge you in 100 millisecond increments, basically peanuts. And there's a free tier, which if you're messing around like we're doing with this, you won't pay anything at all, because I think you can do like 1 million requests before you even start getting charged. I'm not going to talk to her that much, so it's unlikely that I'm going to hit 1 million requests a month. So anyway, the other nice thing about it is, unlike some of the other attempts at this kind of thing that have been done in the past, Google's App Engine springs to mind, and some of the others I'm not attacking, but what's good about Lambda is it can basically do anything. If you can write it, it can run native code, it can run full Java stack. There's no limitations. You don't suddenly run into sort of the great wall of functionality loss that you sometimes hit with these other things. I was surprised actually. I couldn't believe that it actually ran native code when we tried some of the other stuff we're doing at the moment is using Lambda for very high power group computing, and we were using an optimizer that uses native libraries. We were having trouble with it, and I said, it's got to be the native libraries. Turned out it was a bug in the code. Native libraries run fine on there. So basically, you've got full reign to do whatever you want. So a few tools I'm going to show you is, if you look up here, this is the Echo homepage. This is connected to my Echo. And as I do things, they'll come up in here and you can see what she has understood. I can't avoid referring to her as she. She has a female's voice. And it's just natural to sort of say she now. So yeah, she's like a member of the family. How do you connect it? So the Echo is connected to the Wi-Fi here. That took about 15 minutes to get going. I was looking a bit stressed over here for a while because it was harder than it should have been. But it connects up to the Wi-Fi, and then basically it communicates with the Amazon service. And most of the smarts are actually up in the cloud, along with everything else. It's all running on. I'm sure they're using Amazon Web Services as well behind the scenes. But you can see, for example, the stock quotes that I launched or stuff like that, they come up here. So I can say something like, Alexa, tell us a joke.
What did one eye say to the other eye? Between you and me, something smells.
So I've said that whenever there's a pause in the presentation tonight, we're going to get her to tell a joke to fill the gap. But you can see when I did that, one of the things that comes up here is she said, or she's put up there what she heard. You can give feedback at this point, which trains it. It's pretty accurate already, but you can refine the training as you go. And then what comes back is also shown up there. Now you don't have to use this, obviously, but it's one of the tools as a developer that you can use to check what you're doing, what's going on. Right, I also turn to my good friend Venkat Subrahmanyam, who is the inspiration for the style of this presentation, because there are no slides in this presentation. I didn't have time to write any. So I'm doing it Venkat style, which means basically I have a to-do list and we'll just go through the to-do list. So, first of all, preliminaries. Let's say you want to develop your own Alexa skill using Amazon Web Services Lambda and Scala. You need to do some preliminary stuff in Amazon Web Services. I had to go back. I've been doing this for about 3 or 4 months now, and I couldn't actually remember the things that it was interesting this week going back and thinking, what was it I set up to get this working? So if I forgot anything, there's guides online that you'll pick them up from. But several things that you'll need. First of all, I didn't log in from here. I probably need to read. Oh no, I'm still in. That's good. Okay. First thing you'll need an S3 bucket. How familiar are you? Does anybody not know the Amazon Web Services offerings? Okay. I'll hit the ones that we're going to be talking about tonight. There's really only 2 or 3 that you care about. S3 is Simple Storage Service, Simple Storage System, something like that. Basically, it's Amazon's distributed file system. It's a bit like Google file system or whatever. It's a file system that exists in the cloud. It replicates automatically. You can load files up there. You get charged a tiny amount for the storage that you put up there. But what it does is it lets you. This is where things get deployed. So when we create our skills, we actually bundle them up into a jar file, and then they are uploaded to S3, and Lambda can then read them from S3. So our deployment is basically jar the thing up and stick it up in S3. That's it.
Right.
There's a plugin for SBT that does this, so it's even easier than that. So, oh yeah, it is very easy. It's getting pretty good. So I've got two up there. There at the moment, Scala Lambda and Scala Skills. I think Scala Lambda is the one I'm doing right now. I've been messing around with it. There's some play stuff that I've been doing, including it's not just like Amazon Echo skills that you can write here. You can do all sorts of stuff. A Lambda function is just basically something that receives input, does some processing, and produces output. It's that simple, and you'll see in a minute, you get an input stream and an output stream, and that's basically it. It's a very simple API. You can do whatever you want with that. Some of the things that you can do, if you want to do that, is put a web API or a web gateway in front of it, and suddenly you've got a web service where people can actually hit HTTP, they can send JSON in, do some processing, get JSON back again. I've even written a web server with this thing, with HTML coming back out. It works just fine. But the HTML was, I believe, that wasn't its fault, that was mine. So you can do, what is the thing? What's that? That's gone. No? It feels like something's telling me something's wrong, but I don't know. Doesn't matter. I'll ignore it. So anyway, this is where the thing gets deployed. There is the Lambda itself. So let's have a look at Lambda. There's a whole bunch of stuff in. If you haven't got an AWS account, just stick your credit card in and get one. You can play this thing. It won't cost you more than $a few bucks a month to play around with it. And it's like having your own data center on tap whenever you want to do something. It's really cool. So here's a bunch of things. Here's one you guys, I think, will enjoy. Alexa, ask Wolfie.
What is your question?
What is the square root of 50?
5SQRT2.
So that was Wolfram Alpha. If you guys don't know, Wolfram Alpha is like a maths Google.
Founding date, 2009. 6 years ago. Sector, software application company type. Private headquarters, Champaign, Illinois. United States website.
Alexa,
Wolfram Alpha.
cancel.
Shut up.
There was a problem with the requested skills response.
One of my programs is not finished yet. But the nice thing about that is it's actually connecting to Wolfram Alpha through a web API. I can show you the code for that later if you're interested. But it's, that was just a kind of cool thing that I thought, it would be really good to be able to ask math questions. And now I can. As long as you can understand it, you can give me the answer. So let's start out. Let's go through the list of things. So that was the Lambda functions. There's one more thing you need to know about in AWS, and that is the identity and access management. So when you set this up, you need an S3 bucket to put things in. You also need a role created, and convention says that that role should be lambda_basic_execution. It's just what the plugin uses. But this is something that you need to give permission to use S3. I'm trying to remember how to set that up in the first place. Follow the instructions online and look for that thing. But basically what this does is let you upload things into S3 and connect Lambda functions to them when you've got it set up. And that's all you need to do. That's all of the precursor work that you need to do to actually run the Lambda function. So let's have a look at what a Lambda function looks like. Okay, so we've done that. We've done the Lambda role, person size. Oh, I'm supposed to be at the Scala Bay meeting. Right, so that's, the pricing size and timeouts. I'll talk about that at the end if you guys are interested. Okay, so guided tour. How do we write this thing? First thing you need is all good Scala programs start with SBT these days. So you need the various dependencies and you need the settings. There's not a lot here that should be surprising. One of the things you do need to do, and I'm going to turn this into an activator template because there's a little bit of fiddling here. What happens when you create the jar is that it uses a plugin called assembly, which takes all of your dependencies and rolls them up into one big jar file, which is put on up to Amazon's Lambda. if you don't specifically name some of the dependencies that are in here, even though they'll be brought in transitively from other ones, they won't get put into the jar file, and you'll find out that it doesn't run when it's up on Lambda because it's missing dependencies. So some of the things like Apache Commons, this will get dragged in by the Amazon stuff, but for some reason it doesn't get put in the assembly. You know why, don't you?
Yeah, it's probably included as like an optional or runtime thing.
Okay.
They're not runtime, they're optional dependencies, like
Right. So when you start out with Echo, and I've done some of this work for you, the first few times that you deploy it, you'll probably find that there's like missing dependencies, and it tells you what's missing, and you go and Google it, you find the thing, you stick it in your library dependencies, and it starts working after that. So Commons, the logging stuff, they're in there for that reason. And then you need the various Lambda things, the Lambda core, Java core, Lambda for Java events. Officially, Lambda doesn't have support for Scala, but it does have support for Java. If anything has support for Java, it has support for Scala if you're determined. So it's not too hard to get it to work. And then the other part you need is the Lambda plugin, which is written by Guilt. I just the other day stuck in a pull request to improve a couple of things about it. But the Guilt plugin up there, that's my local one because it's got those changes in. What that lets you do is configure what the Lambda function will be and all the other stuff. So here's what you need. You enable the plugin. You've got that role that we created, the basic Lambda role, basic Lambda executable role. That has something called an ARN, which is basically the unique user ID, or the uniquely identifiable UID.
Resource name.
Yeah, it's the UID for the resource. And that role has one of those. You can't use mine because it won't work. You have to make your own and paste it into that role ARN. You give it the name of the bucket. The Lambda memory here, you can use any value between 128 and 1536, I think is the maximum. That's the size in megabytes of the target VM, or the target environment that you can run in. It's an interesting pricing scheme. The larger you make that number, the more you can do in that function, but the more they charge you by the millisecond. So the trick there is to make that number as small as you can, but still get the thing to run reliably. Okay? The Lambda timeout is just how long it will run for before it considers that the whole thing's gone rogue and kills it. This is 20 seconds. You can run up to 5 minutes now in Lambda. That's the hard limit. After 5 minutes, it'll kill it anyway. And then the last thing here is the Lambda handlers. And this is a function name that will get created when we went to the let me get back to the Lambda view here. Lambda. So this function name, like Ask Wolfie, that's what that is. That's that handle. And then the thing that's connected to is a package to a class and the method within that class that it's going to call when that function is invoked. So it's pretty simple. That's a pretty simple thing. The addition I made is that there's actually no reason why you can't have dozens of functions calling into the same jar file. The original Guild plugin just had kind of a one-for-one, which when you uploaded the jar, you've got one function called. You can make as many as you want to, so now you can just provide a sequence of those things and say, this one points at that, this one points at that, and have as many as you want. So that's that. And then the hard part, right, is going to be writing the actual function. Has anybody worked with, I know most of you aren't familiar by the sounds of things with AWS, but you worked with SWF? No? No one here? That's a good thing. Skip SWF. It's the simple workflow. I compared this, Lambda. If you think SOAP and you think REST, SWF is SOAP and Lambda is REST. That's about how much difference there is in the complexity models between the two. SWF is seriously overcooked. It's really confusing. And it's all, no offense, but it's all annotation based, which really doesn't suit Scala very well at all. This is what this is the simplest possible, well, at least the simplest possible Lambda function that I can think of. This is the whole thing right here. So you've got your class, You got the method. This is the class and the method that we were calling into with that. You get an input stream, which is the data coming in from the event. You get an output stream, which is whatever you want to give back. And you get a context, which has some information that you can safely ignore about the function that was called, how long you've got to run, the logger that you can use, and some other stuff like that. And that's it. So what this guy does is it ignores the input altogether. It throws hello world onto the output, and then it just exits. Okay? When we run this, let's go to Shrine. What do I call it? I should explain where the demo is going so that you understand the reason for the naming that I've used. Another thing that some of you will probably know, but the youngsters here will not have heard of, is back in the early days of computing, there was a very silly program called ELIZA, which was a psychoanalysis program. And when I was putting this together, I thought, what can I get Alexa to do? And I thought, Alexa can psychoanalyze me. So what I did was embedded ELIZA into an Alexa skill. And so that's where we're going. So to launch this guy, which is up in the cloud right now, I can just say, Alexa, open ELIZA for a session. Give a second.
Hello, Scala Bay. I knew you when you were called base.
So that was, I've actually jumped ahead a little bit. This is not that. This is the very simple lambda. So let's go ahead and use this one. So all this one does is it takes the input and sticks an output to the output stream. So if we want to run this guy now, let's bring up my terminal over here. My terminal over there. And out to AWS and Scala. Okay. And I can just run update lambda, which the plugin does all the work now. So this will now package up that whole thing. Take a few seconds. Alexa, tell us a joke.
Why is 6 afraid of 7? Because 7 ain't 9.
Oh, what is that? Oh, that should be. I think I know what that is. Create lambda. So this is a bit janky at the moment. There are two commands: create lambda and update lambda. If you don't have a function already, update lambda will fail. If you do have one, create lambda will fail. There's an unfortunate place in the middle where you can, if you change the handles, the function handles, so you have some function handles that exist and others that don't, neither of them will work. So you have to go in and manually delete all the handles and then do a create again. In time, I think we'll fix that, but yeah, that worked this time. So now we've done that, up here, if I refresh this, we should now see a new function. There we go, echo demo. And I can call this one now. I can say test it, and it asks me what kind of input I want. Should ask me what kind of input I want. Oh, it just ran. There we go. So there's my hello world. And if you don't, well, I can show you, but it'll take time. I'll just show you the stuff changing later. Some of the other stuff that you'll see here, it ran in 95 milliseconds. We got billed for 100. Those bastards. Charging me for the extra 5 milliseconds. It gives us any logs that happen. It gives us a bunch of stuff that came out of it. But really, that's all it takes. Now, what about if you want to do something with the input? Well, let's try it. So over here, let's make this a bit bigger. What we'll do is now we'll actually take the input stream and stick it in the stream. So val input equals iodetools.toString is. Okay, and then what we'll write out is the input dot reverse dot get bytes. So we'll just take whatever we get on the input and stick it onto the output. I'm assuming that it's text here. Obviously, it can be binary, it can be all sorts of different things. There is no safety in this. This is This is my kind of API. You can build whatever you want on top. This is dead simple. And if you want to make it safer, you want to do something on top of it, you can. So that's that. Let's update it now. Update Lambda. And Alexa, tell us a joke.
What is black and white and red all over?
A newspaper.
A newspaper.
I meant to demonstrate Ensign to you as well, which is another project that I'm working on right now, which is the enhanced Scala intelligence mode for editors. It basically embeds Scala functionality into your flavor editor. So there we go. It should now be there. It's telling me that that's missing. There we go. Bring in IO utils, and we should be good to go now. Alexa, tell us another joke.
What's brown and sticky?
A stick.
A stick.
My nephew loves that one. All right, what did I miss? Still not from here. Did I not? Did I say this?
Oh, you.
Oh, thank you very much. Wow, eyesight. Okay, let's try again. Can you handle another joke?
Sure.
Alexa, tell us another joke.
What is brown and sounds like a bell? Dung.
That's a bit racist. Right, there we go. Now, finally, we should be able to come up here. What I can do is choose configure the test event. This is what you can pass in. You can pass in anything you want to as this input. They, fairly sensibly have a JSON example in there. We can say something like, stop trying to be clever. Hello. Okay, save that and I'll save it there. Fire it off. Submit. So now when it runs, we get it backwards. So that's how hard it is to write one of these. It's really, really easy to write one of these. And of course it's very easy to abstract. One of the first things I did before I started messing with the echo side of things was just came up with a trait that you can mix in that instead of having to deal with the input string and the output string, it simply gets a string handed into it, and whatever you get back as a string gets put back in. So on top of that, you can then lay a JSON, for example, and a JSON parser on the way in, JSON parser on the way out. I haven't done anything with binary yet, but it's absolutely possible to do because it's just an input string. So you can get a string of bytes in, do whatever you want, put a string of bytes out, and do image processing or anything else that you want to. So, where do we get to in the big list of stuff? We've done the guided tour, check and check. We've done the handle request, create Lambda, show the changes on AWS, and handle input. Now let's do the echo part there. So, it's a bit more complicated with the echo, and it's also time to talk about one of the things that isn't so good in Lambda. Now, speed is a really interesting thing. It doesn't, GPUs show that it doesn't matter what your clock speed is, if you can throw enough cores in something, you can get ridiculous performance. Just look at prices. So, the thing about speed is that when you're running some kind of massively parallel system, it doesn't matter if it's slow, as long as you can run enough of these things at one side, which Lambda is very good at. For interactive skills, that you're only running one thing, Lambda's pretty slow. I think we did some testing, because we're actually, as I say, using it for some really high-powered stuff with Monte Carlo simulations. And it runs in about 2 minutes what the data center was taking over an hour to do on big machines. So a big win from that perspective. However, it's about 5 to 30 times slower than running an EC2 instance, depending on what kind of EC2 instance you've got. So even the smallest EC2 instance will run code about 5 times faster than Lambda does. Where that gets to be an issue, in particular with Scala, and this is one of the first things that if I ever get to talk to some of the folks at Amazon, I would ask, is that it's very quick to pull in libraries that it knows about already. It's already got a runtime set up. It's got standard libraries there. Any that you need to package up, and any that have to go through the static initialization, they take time. And it's noticeable. Like, as you start to drag in JSON parsers and stuff like that, the time that your function takes to run starts to go up. It goes up to 8, 10 seconds, something like that. It's not horrible, but it's noticeable when you're trying to interact with it. You'll probably see that when we start using the speechlet. The speechlet's not super huge, but bringing in those extra dependencies, if it has to do the initialization, it takes time, yes.
So that's where every request they don't cache, it's not like it's hot loaded.
That's an excellent point. No, they will cache and they will reuse existing ones, but you don't have any control over when that happens or when it doesn't happen.
So you could be booted every time.
Yeah. And it works to your advantage when you do run one of these big slam dunk HPC things and you're chucking loads of stuff at it really, really quickly. Then all of a sudden it's like, oh, I've got one of those, I'll just reuse that one. And it's really, really, very quick. When you're interacting with the echo, it has a tendency to stop or lose it midway through. And then all of a sudden there's a big pause, like a 5 or 8 second pause in the interaction. The little blue right spinny thing goes on, so you know what's happening, you know something's happening. But those kind of pauses, the other thing that happens is anything that's persistent or anything that's in memory is lost if the function dies. Okay, it can kill the function after any particular run. You'll see that, I mentioned this in Eliza, because when we start talking to Eliza, at some point it will switch functions and all of the memory that she's got of the conversation so far will be lost. At which point she'll get really stupid again and start asking the same questions. She probably will say something like, let's talk about something else, which is the standard response when it doesn't have anything to keep in the memory. So if you want to persist stuff, you have to actually persist it. You can rely on a function running to conclusion, unless there's some kind of exception in it, but you can't rely on the fact that that same instance will be used to service the next function. Of course, it has to be any state that you want to bring along from one to the next. You're going to have to manage that yourself.
So this is running JVM eventually at the back
It is running the JVM at the back end.
and
Yeah.
they have the JVM warmed up and everything.
They do have the JVM warmed up. They have a bunch of the standard libraries ready. I think one of the easy, well, I say easy. There's a lot of these things I kind of throw around that I've never actually tried to do myself. They sound easy to me. It seems like, because that, if we go back and look at that function, you can see there's nothing stateful in here. And if this did any kind of, if we wanted to do any kind of static initialization, we could do that, and this function could be called repeatedly, and it wouldn't have to do that each time. So it seems to me like there should be some way to do a sort of virtualized Docker kind of thing, where the static initialization could be done. All the things that you need to load, like JSON parsers and stuff, are loaded up ahead of time. And then it snapshots off into S3 like a version of that thing ready to go, with everything warm. And then it brings that back to service the functioning time. And if they could do that, it would eliminate that whole static startup kind of pause, that whole experience there. So that would be really nice if anybody would ever do that. Yeah?
Does Echo have to talk to a Lambda endpoint?
Oh, no.
We can talk to anything, okay.
Echo can be set up to forward to your own machine if you've got it running. You can run EC2. Of course, well, you can run an EC2 micro instance free, I think, can't you? So that would probably do well enough. At some point, you're actually going to have to start spending money if you do that. But that's the nice thing about Lambda is it just sits there. I haven't spent any money on Lambda yet. I've been experimenting with it like crazy. I've spent companies' money on it, but not my own. So, right. So let's have a look at what it takes to write a Alexa skill. Oh, cancel. Thank you. She does pick up her name in conversation occasionally. You have to say Alexa when you're at home. Otherwise she hears and feeds it straight back to Jeff. Anyway, so There's a bit more involved. One of the first things you need to do, it's still experimental, I think, at the moment. I didn't know. All the time I've been using SVT, and I didn't know about this until I did this. Because I'm so used to just using dependencies from Maven, Maven or Ivy dependencies, and you just stick them in the file and it downloads them. I didn't know you could have a lib directory where you can put jars and they get picked up automatically until I did this. So that's what you have to do. Right now, if you want to use the Alexa Skills Kit, don't say anything, then you have to register as a developer with Amazon. It's free and it's not hard. And then you actually download the jar file, you create a lib folder, and you stick that in there. This is one of the reasons this isn't an activated template yet, is it would violate their terms of service if I was to upload that jar file in a publicly accessible form. Right? You have to actually sign up for it. So I could make the template, but then you'd have to go and you'd have to sign up for the thing, download the jar. It seems a bit messy. I think I'll just wait for the dependencies to become available and then make it available. But anyway, you stick the lib in there. It's called Alexa Skills Kit, I think. So it's in here. It's in this lib directory. Yeah, Alexa Skills Kit. It's in. Cancel. It's at 1.1 right now, and it has a bunch of stuff. It doesn't take too long to start up, but it does add a few seconds to the beginning of the Lambda processing in Scala to actually fire it up and run it. I think that at least will improve, because I imagine once it becomes like a really supported thing, they'll have a kind of ready image for this that doesn't have the static initialization type for the actual skills. And then the rest of it, and again, this won't mean a lot if you haven't done a lot of work with Amazon Web Services, but I've done an awful lot of it at this point. I really don't mean for this to sound as mean as it's going to. Amazon Web Services is a classic Java API, and then it's very, very side effecty. Everything is a setter, and you have to go through and set things, and mutate things like crazy. And so one of the first things you do in Scala is you wrap it so that it doesn't have that kind of, you hide all that kind of ugliness behind the scenes. So there's a lot of stuff that I've created this abstracts class of Scala speechlet for that just hides all of that so that you don't have to see it. It's all the stuff like creating envelopes and checking. There's all this imperative code where if it's a new session, you have to do something differently, and all this kind of thing. So all of this is hidden right now. And there's nulls all over the place. Good Lord. So one of the first things I do is wrap everything in options, so I get rid of the nulls. You know about that trick, right? If you take something that's potentially nullable and you stick it in option, it either becomes some of that thing or none. So now you can use it in for expressions and stuff like that. So this whole bit of code is probably something I'll just put in a blog post or something so people can use it. You can extend this Scala speechlet, and it makes it very easy to write an Amazon Echo skill without having to see any of this kind of stuff in there. One of the right here you'll see, this is the handle request. This is the same thing that we wrote in the other one. It's exactly the same. It comes in, it's got an input stream on the way, and it's got an output stream. It's got a context, and the first thing you do is use the skills kit to turn it into a speechlet request. So it first of all goes through to a byte array as the input stream. Then you create the speechlet request envelope from it, and that comes in as JSON with a whole bunch of extra information. It comes in with the request, and it comes in with all the context. Are we in the middle of a session? Is this the start of one? Which intent, we'll see the intents in a minute, which intent is coming in? So when we're well beyond the just call a function at this point. This is like a really seriously re-entrant conversation now. When you write one of these, you start holding a conversation with the box, and it remembers, well, it doesn't remember, that the Lambda function has all of the context of what's happening in that conversation. It could be a different Lambda that you're coming into each time, you don't know, but at least you have that context there. So anything that's in that, it's a bit like a cookie on a web browser.
So the context comes in with every request?
It does. Now what I haven't discovered yet, and I actually hadn't thought about it until now, is whether you can put things back into the session to go back to the client like you can with cookies. Because that would be a way to get some kind of persistence between things for your own data. Right now it's really just you know, we're in the middle of this session. You've got this much time left. You know, this was the last thing that got sent back to the user, and you have a logger and some other stuff, and this is the function that's being called. So there's a bunch of information in that. And then there's the actual intent, which is the part that you define yourself. If you've done any Android programming, intents are the same kind of thing as they are in Android. It's an action that's being requested of the server or of the service. So you sort of, you know, you have an intent to open a web browser in Android, for example. Here, the intents are whatever you define, and they can have parameters. We'll see how to do that in a minute.
Is that what we implement? Like if you ask two questions in quick succession, you can answer to the second one or to the first one?
If you ask two questions in quick succession, the first one will actually get cancelled, I think, in the second one. But I think if you try to tell them to do two things at once, one after the other, it'll actually cancel the first one and do the second one. It's re-entrant in that, well, we'll see in a minute, but you choose whether the session continues after this. In other words, when I launch, so when I said Alexa, launch Eliza for a session.
Hello, Scala Bay. I knew you when you were called base.
Right. See the ring went off there? That was the end of that session. That's one invocation of that program. And that's because one of the things that I did, we'll see in a minute, is I said after that hello, after saying that greeting, the session ends. There's a Boolean flag that says this is the end of the session. If you set that to false, the little ring stays lit up and she's having a conversation with you. So now you're doing a back and forth, and this is where you can, you know, stick things into a database or put things in Eliza's memory that occasionally get lost and stuff like that. So we'll see all of that in a minute.
But if while you go to Eliza, if you ask her to take she's not going to take it, you're going to continue talking to Eliza, right?
You need to say that just a little bit now.
So while you talk to Eliza, you're going to ask from your group, you're not going to take it, you're going to continue to talk to Eliza, right?
No, that's right. You're actually in the Eliza program. Unless I create an intent that says, tell me a joke, which I could do, and then Eliza can tell me a joke and still be in Eliza. So, yeah, but it's sort of like you're starting the program and executing the program, and then when that session ends, the program exits, and if we want to do it again, we have to launch it again. When I used Wolfram Alpha, the Ask Wolfie thing that I did before, that one stays alive, I think, until I say thank you. I put it in there so that when I say thank you, it shuts it down. So that I can keep asking math questions, and it has a timeout of 30 seconds or something like that. But I can just keep firing stuff at it, and keeps reading it back to me and waiting for the next thing until I'm ready to finish it. So, yeah.
Are you saying that the speech-lit request has a context that comes from the input stream that is separate from the Lambda request's context?
That is correct. Yes, this is sort of like the environment getting handed in by the Lambda runner.
I'm just waiting for you to say servlets. I just want you to say
It
servlets.
is. There's nothing new under the sun, right? I mean, they've reused a lot of ideas, but yeah, this is sort of this is your container. This is the logger.
This is container.
Yeah, this is the container. This sort of has your current session where you are in your conversation. So this is like a back and forth with the user program. This is the Lambda runner with all of its information about the size of memory that you've got available and how long you've got to service this request and all those kind of things that we set up in the Lambda configuration. So anyway, this hides that. It does all the speech-lit kind of setup. You can see this is a pretty. I'm going to clean this up. This is a pretty lengthy bunch of sort of semi-imperative code where there's lots of what happens if it's this, do this, and that kind of thing. I've tried to clean it up as much as possible by doing things inside of options and tries and stuff like that, so that it's at least a little bit more. It feels a little bit more functional, but there's a long way to go on this stuff. The thing is, though, it's all hidden behind the scenes, so you don't have to see any of that. You can just use it. Similarly, for the speech-lit response, when I showed you this thing. These things are called cards because they look like cards, and this is the response that you get back. It's in the form of a card. So when you want to make a response, you actually create a simple card. You can set the title, you can set the output, you can set a few different things on it, and then finally you throw the card into a response, and you give that back again. Because I love case classes, I think case classes are the greatest thing since sliced bread. That is my API. So there's a case class called Scala speech-to response. All you have to give it is the title, the output, and whether it should end the session or not. So the title is the name of the card. The output is what it should say. And the Boolean at the end is, does this end the session or does it keep going? And the rest of this stuff is just all of the kind of side effecting stuff is hidden behind that as response. So you don't have to see it. So actually using this thing, demo speechlet here, when you extend Scala speechlet, you give it the name, and you have to define 4 methods. I think probably I'll end up, I never overwrite the last 2, so I'll probably just provide default ones for those, and so you don't have to do it. This is so that when a session starts and when it ends, you can fire things up to happen in the web, so you can choose to override them if you want to. I don't usually bother. It's like you already get the first intent when it comes in anyway, so I just kind of do that. The on launch and the on intent though, these are the big ones. So the on launch is sort of like your greeting. You've just started the program. So when I say, Alexa, open an ELIZA session, or no, Alexa, open ELIZA for a session. That's taken longer this time, so you never know what that startup time is going to be. But in a second, we should get it back. That's going to say this. It's going to say, hello, Scala Bay.
Hello, Scala Bay. I knew you when you were called base.
And then the true at the end there means that it's the end of that. You know, it does that one thing and it exits. Not very useful in itself. The on intent is where the real action is. So let's go ahead and stick something in there. Let's make it do something a bit more useful. The other thing I should show you is ELIZA. This is another reason I haven't made this template, activator template, is this is just some code that I sort of found on somebody's GitHub. It's open source, but I need to actually do something, I don't know, like approach them and say, hey, can I use this in my demo? Because right now I just copied and pasted it into my code. I didn't want to add another dependency. There wasn't a dependency to add. And it's just a very simple ELIZA implementation in Scala that just turns answers into questions, that sort of thing. You'll see what it does in a minute. Okay, so how am I doing for time? Not very well, so I'm going to cheat. Use my cheat sheet to save time. Let's just put the on launch and on intent in, copy and paste them in, and you'll see the difference. So replace these two, and then we'll just talk about it. So on launch gets the same thing that we had before, but now instead of just giving back the string, the hello world thing that we were doing, we actually call ELIZA with the input hello, and ELIZA is programmed to give you a response to hello. So we're already starting to use ELIZA for that kind of thing. Now, however, I've said false. This is not the end of the session. So ELIZA will greet us, and then it will wait here for the next input. It will actually wait for us to say something. The second thing that will happen, and all of the future ones will come in as intents. So we get these intent requests in, and I've defined 3 of them. There's hello, which if I say hello, she'll actually say hello and whatever. If I say goodbye, that ends the session. That's it's off the edge of the screen, but that has a true at the end. So that's the thing that we use to exit the program. We just say goodbye, and she says, that was a great session, feel better soon. And the third one's the clever one. That's the ELIZA intent, which I defined. And this one has a free-form section in it called a statement, which is anything that I say gets parsed into text for me. It gets recognized from the speech into text, and it gets fed into ELIZA, and then ELIZA will produce a response. So how do we do that? Let's have a look really quick. Actually, let's save this and get it uploading. So AWS. Let's hope I got everything there. So what we're doing now, let's have a look at the other parts of the system here. Somewhere I should have the, here we go. So, I'm cheating a lot a bit because normally you'd have to set this up afterwards. What's happening right now in the background is that that whole thing's getting jarred up again, it's getting uploaded into S3. The function that I asked for, which is that handle request, which was in the superclass, that's getting registered as the endpoint for when I start using the ELIZA framework. There is a trigger on that, which I'll show you when it gets created, when it gets set up. And the trigger has the information that's in here, which is, the trigger comes from the Alexa skill, or the Amazon skills kit, the Alexa skills kit. And so that is actually triggered. Oh, that's right, there's an extra setup there. You have to connect your account to it. I can't remember how I did that when I was too long ago. You'll find it online somewhere. But that makes my Echo capable of firing a Lambda function through this thing. And the skill itself is defined like this. So you say, the name of it is ELIZA. It's ELIZA for a session. This is the ARN. I'm probably going to have to change this in a minute because I think I wiped out my other one, so I'll have to replace that ARN in a minute with the right one. But the really clever bit is the interaction model. So here, we define the intents that we want, which is a hello intent, a goodbye intent. These are very simple. The third one is the clever one. That one has ELIZA as the intent, and it has a slot in it, which is a statement of type literal. And there's various things that you can do. You can put numbers in, you can put dates in. You can even define your own things. If you want to put foods in, you can actually create custom slot types with particular words and define what we want it to mean. Literal is the most general one. It basically means anything I say, stick it in a string and pass it in as a parameter to the thing. So that statement will be anything I say to ELIZA that isn't hello or goodbye, basically. And then down the bottom here is the natural language parsing bit. You have to do sample utterances. This is actually really good. The more of these you can provide, the better it's going to be. But I've got, for hello, I've got a bunch of them. I've got hello, hi there, hi ELIZA, and help me. All of those will give me the startup. Goodbye, I just put one in because otherwise it has a tendency to end the session too soon. I actually want to only trigger it on goodbye. And then the third one is a bunch of things that have, the real key here is some of the first few words. So I think, I have, I wish, why can't I, what do you, why can't you, I am, I was, how is it? Those are the things that we want ELIZA to recognize as the conversation that we're having. So when we're sort of being psychoanalyzed, these are the ones that kick off that intent. The intent name goes there, and then basically what you say is this is a statement, this is a statement, and these are the slots that those things get put in. And it's not just these words. That's the key that I'm trying to get across here. These are only examples. By making these broad enough, you can say anything you want to that's approximately like that, and it will get speech recognized and passed in to ELIZA. So let's see how we're doing over here. Oh dear. What did we miss? Oh, maybe it's an update number on it. Yeah. Alexa, tell us a joke.
What do you call a seagull that flies over the bay? A bagel.
Oh, that's terrible. Yeah, so it's because I needed to do an update, not a create. That's it, it's done. Okay, so let's make sure everything's connected up. So we need to go back into the Lambda here. Lambda functions, demo speechlet, ask speechlet, demo for base. We can test this if we want to. So let's try a test and see what it comes back with. It takes a few seconds. You will notice it takes longer with the speechless because of the initialization. So there we go. It's basically the launch of the session, but it is working, so we can see that the Lambda function is ready to go. And the triggers, the event sources. This is the code of it. Let's show you these things. There's a whole bunch of them. These are what you can trigger Lambda with right now. So the Alexa skills cancel, and the Alexa connected home. Those are things. The AWS internet things, which I haven't messed with yet. I've been having so much fun with Lambda, I haven't got there yet. But that's going to be awesome when I get that going as well. CloudWatch, Cognito, Dynamo, Kinesis, S3, SNS. I think SQS is on there, isn't it? No, that surprises me. But I guess you can always fire it through SNS anyway. So, but the key one for us is the Alexa Skills Kit, and that's what this is here. You set that up. All that does is connects my Echo to this. To actually control what happens, you have to go to this other part, which is the it's a separate part right now because it's still in kind of beta. It's not as part of the whole AWS offering, so it's in this other place, which is a bit weird. But if you go in here, you can see Eliza, and this is why I have to say Eliza for a session. This is another thing I wanted to mention while I remember it. You have to choose these quite carefully. I went through a few different iterations before I came up with Ask Eliza for a session. I tried trying to get it to psychoanalyze me. I tried Eliza to psychoanalyze me. Totally freaked out on that one and never got it right. So these launching phrases, you have to kind of play about with a bit to get the right one. The other problem I have is I can't say ask a lot of the time because I have an English accent and she doesn't do well with that. I have to go ask. And then she kind of gets it. So I tend to go with open or launch because it does a lot better with that than with my ask. So anyway, let's give it a go. So now we should be able to say, Alexa, open Eliza for a session. Come on. You can do it. Not usually this slow.
How do you do?
I'm good, thanks, but I keep dreaming that I'm a space alien.
How long have you been good, thanks, but I keep dreaming that I'm misplacing you?
Oh, about 20 years.
Why is that?
I don't know.
Why don't you know?
I don't know why I don't know.
Why don't you know I don't know?
Let's talk about something else, Eliza.
Please tell me more.
Okay, I used to think I was a fish.
Let's change the topic.
Thank you. Goodbye.
Let's talk about something else.
Goodbye.
That was a great session. Feel better soon.
So now it's finished. Not a great demo, I'll give you that, but it shows the potential. I needed something that would do a conversation. The key here is that, you know, I've obviously done a lot more with it than just a stupid Eliza thing. You've got full reign, you've got the whole internet to do whatever you want with. You've got all your connected devices at home now. Anything that has a web service you can connect to. I've seen somebody literally create a Jarvis program to control their home entertainment system, which is pretty cool actually. I just saw that today. So they can say, Alexa, cancel. Ask Jarvis to turn on the television and find some baseball. And it does. It does all that. So you. That's true, yeah, there's other ways to do it, but it's so much cooler when you do it yourself. When you spend hours and hours working on it, it's much cooler that way. So, and what we can also see is the interaction we just had. So, all the things that Alexa heard when we were doing that was, okay, used to think it was a fish, very close. What's the point of something that let's talk about? She actually does it better with speech than this one. I don't know. Why is that? I keep dreaming that I'm misplacing me. I doesn't like space alien, apparently. But anyway, you get the idea. So, let's see, was there anything else I wanted to cover? And then we'll just go to questions, I think. ARN, compact jars, all through the pieces. No, I think that's about it. So, all I can say is, first of all, number one, you've got to get one of these. Number two, it's not hard to get started with this stuff and mess around with it. You can bury a lot of time in it, admittedly. But I have lots of plans, particularly for the home automation side of things. The home automation stuff that the Echo has already is pretty good, as long as you've got the supported stuff. The difference is, like my garage door opener, for example, is not on the supported stuff, but there is a web API to it. So I can write something that I can basically open and close my garage door and check that it's closed when I go around to outside. Yeah, that's a lot of work to go through rather than just opening the door and looking, but it's not the point. The point is it's cool. So you can basically do whatever you want to on it, and yeah, it's a fun hobby. So, all right, questions? Yes.
I'm just curious about community and portals or products. Do you think what do you foresee happening in terms of developers developing services or community products?
So, although it's early days for it, any of these things that I've written, that's a great question because I would have forgotten to talk about that. Any of these that I've written, like Eliza, I could take right now and I could actually submit it to Amazon. And if it was accepted, which I hope it wouldn't because it's an awful program, but if it was accepted, it would actually become a skill that other people can use on their echoes automatically. So I've actually got a bunch of those. Let me show you those really quick that other people have already written. Under settings, I think it is, skills. Skills. Do you see it? Oh, thank you. That's it. So these are some of the skills that I've actually, or the angry bard. Alexa, ask the angry bard for a bird.
Okay, I'll wait. Please say ready when you're ready to suffer an indignity from Will Shakespeare.
Ready?
Thou art based in a cut purse from the play, The Two Noble Kinsmen.
So this is Shakespearean insults, if you've ever done that. They're quite fun. Shakespearean insults are great because you can totally disrespect somebody and improve your cultural status. So there's some new ones that I haven't seen before. So automatic, check where the car is, bath times is up there now. So these are skills that other people have written. And if I wanted to, if I was proud enough of any of mine, which I'm not yet, although the Wolfram one is getting close, then you should actually put those up there and get them approved, and then other people can download them and use them. That's a lot of stuff. So that's, yeah, you can do that if you want to actually try, and I think eventually they're going to try and allow you to make money through this as well. It's early days of that yet. I think you're pretty much doing it for free right now, but it's kind of cool. So, did that answer that?
Well, then another related question is Watson level AI. I mean, I'm just curious as to how that sort of initiative might evolve, whether this would provide context for that.
It's interesting. I should come back and do a talk about Watson sometime, I think, as well, because Watson is staggeringly good for about 70% of the time, and then 30% of the time it produces the most random shit you can possibly imagine, and it really can't be relied on at all. So while the intelligence is really high, potentially on Watson, the failures are far greater. I'm working with it a lot right now. Whereas with this one, the flexibility isn't high, but it rarely gets things like totally wrong.
And that's the commercial Watson is Watson like compared to the real Watson that tremendous horsepower behind it.
Yeah. So I'm using the natural language classifiers right now to try and pull out wine characteristics from what people say. When somebody says something like, I want a red wine that goes with hamburgers and hot dogs and doesn't cost too much and will still make me look fancy in front of my friends, it's supposed to come out with a bunch of stuff that's useful out there. And usually what it tells me is I need a Spanish something or other, and it gets it wrong a surprising amount of time right now. So there's a long way to go with that. I'm actually more impressed with the language parsing and handling capabilities of this than I am with the NLCs and Watson at the moment. That said, I haven't talked to their engineers yet, and I think I'll probably get a major boost on it. All that I've got right now is just from what I've read on the web and kind of the usual stuff, and I'm sure that a couple of hours with one of their engineers will be all the difference in the world. So I'm hoping it will, because otherwise we have to rely on that. Anyway, yeah, so anything else? Yeah.
Those example ultras going on, were they just biasing the speeds? I mean, you didn't
Yes.
know what happened.
Yeah, so that's the same. I had a good ground with that because that's the same sort of thing that you do in Watson. Basically what you have to do, the whole idea with these NLCs is not that you cover everything. It's not writing a script for what you want to interact with. it's providing enough diversity in the grammatical structure and the sort of topics that you want to talk about that it defines a domain within the whole the whole available domain of speech. You're sort of trying to focus it on a particular area. So I can actually show you some of the wine ones I've got if I've got time for this. I can pull it out really quick. But I can show you the sort of thing that you do for classifying them with speech. What am I not doing my recent? What have I opened this? There we go. Wine Explorer. Maybe I'll come back to that at the end or something because it's taking too long now. But yeah, what you're trying to do is give it enough variety to tell it sort of what you want to talk about. And the idea behind the AI part is that once you explain to it that, for example, a Cabernet Sauvignon goes with a nice juicy steak, it should be able to figure out that a T-bone or a New York strip or a tri-tip or any of those would pair well with the Cabernet. You don't have to explain to it that a tri-tip and a New York strip and all those things are also kinds of steak. So you teach it the basics and then you assume that it's able to make enough connections behind the scenes that it understands the rest of the conversation. So in my example, what I was really doing, more than anything, most of it's rubbish in there. Where is that? This one. Most of it is rubbish, except from the first few words of what I really want. So I wish the pixies would leave me alone. I figured that was a funny thing that somebody would say if they were a bit insane. But the key things that I was trying to get is, I'm trying to make a statement that starts with, I think, I have, I wish, why, what, who, when, how, all of those things that are sort of questions and the sort of thing that you would talk to a therapist about. Not that I've ever been to one, but I imagine that's what a therapy session is like. So that's kind of what I was trying to do there, is train it up to the kind of things that I expect it to listen for and turn into speech that will feed into the Lambda function. So yeah.
How do you see this the more complex applications? I mean, the natural language is redundant, right? So you have many ways to say things.
Yeah. That's the part that Watson and this are supposed to do for you. So one of their training examples is weather conditions, and in particular trying to classify temperature versus kind of whether it's going to rain or not, the precipitation. So you train it by how hot is it, am I going to need a jacket, those kind of things. Now, am I going to need a jacket is an interesting one. Because you could train that for both. You could say, I need a jacket because it's cold, I need a jacket because it's going to rain. So you're sort of training it in what these things actually mean in terms of the classification. And you try and provide it with as many good examples as you can, but then you have to assume that it's going to get the rest. It's going to fill in the gaps from context, which is the part that the MLC is supposed to get.
So do you think from more complex cases where people can, let's say, have multiple entries, like for example, starting with IP, like you have 10, 20 IPs, right?
You could, but I think once you've got one or two in there, that's probably all you need. You probably want to cover the bases of the other things that people might be asking this particular program. So I can't remember what I did for Wolfram, but I think it was pretty simple. Let's have a look. Back to this skills, Wolfie. And the interaction model here is just what is. And these are all just the questions. So what is, when is, how tall, describe, why, convert, tell me. Those are things that I can imagine wanting to know from Wolfram Alpha. So, yeah.
So the voice recognition, you said it had trouble with your accent. Does it learn?
You can train it. I've trained it, and it's pretty good at my accent now, apart from ask for some reason. I cannot convince it that the way I say ask is correct, and everyone else is right. I haven't been able to do that yet, but most of the rest of the time, it's actually pretty good at understanding me. So I can say, for example, Alexa, put a Ferrari on my shopping list.
I didn't find that in your past orders, so I've added Ferrari to your shopping list.
Oh, there we go. I'm getting a Ferrari tomorrow. That's awesome. Yeah, it sort of learns, but it's very good. And I wouldn't have expected, without some serious training, that it would pick out something like Ferrari. That's a tough one, right? I work with NLC quite a lot now. You get a feel, kind of an instinct after a while, for things that you think a computer is going to recognize and things that it's not.
But that's a Ferrari, or you just put a tag Ferrari?
Sorry?
If you look at what is
It's actually, so that's one of the built-in skills, and that's actually on my shopping list now, so there we go. Ferrari and kind bars along there.
It's available in other languages too, so I think.
Oh, I think so. Yeah, I haven't looked at that, but I'm pretty sure they've done that. I know Watson is. Watson's all over the place on that stuff, so I don't know about the Echo. I'm afraid I'm a typical ignorant Westerner that only speaks one language, so.
Oh, that was just American.
I'm definitely a first world. No, they taught us French in school, but the English and the French don't really like each other. I got that as soon as I could. Anyway, yeah. So,
So is the interaction model always voice in, voice out, or is there like, I was going to say like a second screen, but it would really be a first screen? Can the output be, Alexa, send the traffic conditions to my other thing? Is there any support model built into that?
Yes. In fact, it does fall back on that sometimes. Cancel. It was listening to what I was saying. It does that. It's a bit creepy. There are things that it already says go and look on your TV, because it sends them to, because I have a Fire TV at home, and it knows about that. It's on the net. It's Amazon's got this down, whether you like it or not. They kind of know all the things that are on your network that they have in mind. So as soon as I connected this up, it's on my Fire TV. Sees it knows. Actually, this is kind of cool. But anything you order from Amazon, I don't know if you've ever done it, automatically comes set up for you. If you've got Prime membership, I think, as you order it, they actually do all of the customization ahead of time. So when you start your Kindle, all of your books are available on your Kindle without any further setup, things like that. They do this for the Echo as well. So when it came, I connected it to my network and immediately knew I had Prime Music and all those other things. You can also send things to the screens yourself if you want to. I haven't tried that yet. All of my interaction has been voice. But that simple card that I did, there's other forms of cards that you can spit out that control what that response is. The other thing, and this is the biggest ask I have, and I know that there are some serious considerations. I'm not foolish enough to pretend that there aren't a lot of considerations about this, but you can't push to Alexa. You can't push down to the Echo. You have to initiate a conversation and continue that conversation. What I really want to do, for example, is have, when somebody mentions my name on Gitter, I'd like her to come up and say, somebody's put your handle on Gitter, and announce it. There's no way to do that. There's no push down. There's no uninitiated push down right now. Now, I think that's kind of dodgy, because do you want this thing going off all the time? But if it was controlled by you, yeah, I would want that. I want to be able to say, I want to be notified about these things, and there is no push notification service. Right?
So can it only be in one context and one intent at a time? Can you only have one ongoing conversation?
You can only have one ongoing. I don't know how you'd manage more than that.
Because you could say, put me in a meeting with my team that's remote, and it's just sitting there, and I want to talk to Dick or.
Well, if you wanted to do that, if you wanted to. See, the way you could do that is...
I want to replace the speakerphone with this thing.
Yeah, well, I'd like to do that too. It doesn't do that yet. That's actually one of the things that I would really love for it to do is, I can't make phone calls through it right now, which seems like a major omission. I think it's got to be coming, right? It's just early days for it.
I mean, you could write something, Lambda type of thing that will send the
Well, I could certainly write a Lambda thing, particularly if I've got some kind of, what's the asterisk? If I was running asterisk at home, I can have this thing.
Or there are services that will do that instead of asterisk, right?
Yeah.
You could have Twilio do this thing instead of asterisk.
That's true. I could have it call me on Skype and then put the call through to the other person at the other end. So I can have it do all of those things because I can write a Lambda function to do it.
Right.
After that, though, that would be out of the picture, so then I could use it for other things. And I suppose I could get it to hang up at the end if I wanted to. But the idea would be that I would have it initiate the call, but then this could drop out. The asterisk is off doing its thing to the side here.
So that wouldn't be the source of sound or microphone?
No, you can't use it like that.
That
right now.
sucks.
Yeah. I think give it time. I think it's got to be coming, right? I mean, this is basically a sort of a Kickstarter project. It's like the best Kickstarter I bought into. And they're still developing like crazy for it, and there's lots of stuff coming out. I think the push notifications and having the ability to use it as a kind of speakerphone are two of the things that are really high on my list to make it even more useful. It already reads my audiobooks and plays music and all the other stuff, though. It's amazing how much I use the thing already. So, yeah.
Yeah, actually, I was. Okay. So, does it do mass collection, or does it send you samples, or is listening, or while
It's only listening. It's only actually listening when the blue ring is on. It's always listening for the keyword to activate it. Let's push the little. That's the. We can now say Alexa, Alexa. It won't do anything. But it's sort of like the computer on Star Trek. You have to initiate the dialogue by saying computer, and then tell it what you want it to do. If I just say make me a sandwich, it doesn't do it. If I say Alexa, make me a sandwich.
I wish I could. Cooking is beyond me at the moment.
I didn't know it did that, but that's kind of cool.
It's because you have a pseudo.
Yeah. Alexa, pseudo make me a sandwich.
Well, if you put it like that, how could I refuse?
I can't believe it. I can't believe that works. Somebody there is a oatmeal fan, I guess.
One more. So, what about the Amazon Fire? So, can you do you envision that similar?
Actually, funny enough, so the technology, the technology is not just this thing. Okay, it's actually it's sort of a blanket name for a bunch of technologies that Amazon does. This is just probably the most consumer-facing one of that. You know those little dash buttons? They use what they call the Alexa Cloud as well. There's a whole bunch of things that are sort of connected to this pulsating brain, I guess, at the center of the Amazon Internet. The Fire TV has just had the voice technology added into it, which is really exciting for me. This is a great little speaker. It does a good job in my kitchen of filling the kitchen with music. It's nowhere near as good as the lovely stereo I got for the front room. And I always said it would be great if I could have the smartness of that, but the quality of my stereo. With the new Fire TV, I've got that now. So you actually can tell it to play music or read your book, and it comes through the big speakers in the system. It's like now having a whole house operating system. So you can actually get it to do stuff and it reads it out through the big speakers, it plays music for you, that sort of thing. So that's built into the new Fire TVs and the Fire TV stick, and the old ones are getting a software update to get them that as well. So then that's actually pretty useful. The other thing I would say is this is too big. I travel way too much right now, and I've become really addicted to having this thing around. And when I travel, I really miss having it around. Now my little Fire TV stick, I can actually take that with me when I go. So I have Alexa on the road, which is good. So yeah, this is I can't get it across well enough. This is the coolest thing I've played in absolutely ages. This is better than Lego Mindstorms. This is really cool. Okay. I think that's it. Thank you for
They have to be cleaned up after.
Oh, it's a